Let's talk about implementing a retry policy first. Sometimes requests might fail due to temporary hiccups in network traffic or a bad connection. A retry policy can help with that. Such a policy states that if a request fails, it should automatically be tried again for a set number of times. We could write that code to retry in our methods that call the API, but it's in fact a perfect use case for using a delegating handler. Let's check that out. In this demo, we'll implement our first delegating handler, one through which we'll implement a retry policy. So let's add a new class. We'll name it Retry Policy Delegating Handler. Such a class should implement the Delegating Handler abstract base class. That's defined in system.net.http, so let's add a using statement by pressing enter. And let's peek at the definition of this. First of all, delegating handler derives from HTTP message handler, so it is a custom HTTP message handler, one which can optionally call the next handler or inner handler once it's finished its work. That matches what we learned on the diagram. We see two constructors here, one without an inner handler and one with an inner handler. The inner handler can also be set via the inner handler property. The important method we're looking for now is sendAsync. It's by overriding this that we can execute our custom code. So let's do that. There we go. So what do we want to do in this method? We want to send the request to the next handler in line and check the response. If it indicates failure, we want to resend the request. But we don't want to do that endlessly. For example, a 404 not found can be the result of a mistake, like inputting the wrong URI. If that's the case, retrying it will result in failure again. So we want to limit the amount of retries. Let's add a field for that. Maximum amount of retries with a default value of 3. Now, that default value is 3, but the default value for this sounds like something we'd want to be able to choose. So let's add the necessary constructors that accept such a parameter. We have one constructor accepting the parameter that calls into the base constructor and sets the maximum amount of retries to our private field. The other constructor we want to implement is one that also accepts an inner handler, which calls the base constructor that also accepts that inner handler. We saw those two constructors in the delegating handler base class as well when we inspected its definition. On to the implementation of our sendAsync method. Currently, this calls into base.sendAsync. By doing that, we're passing the request to the next handler in the pipeline. But we don't just want to do that once. We want to do that for the maximum amount of retries value. So let's make this method async and let's implement it. By calling base.sendAsync, we're passing the request to the next handler in the pipeline. But instead of doing that just once, we keep passing it for, at most, the maximum amount of retries value. So if the response indicated success, we return the response. If it doesn't, we try again. And if the maximum amount of retries has been reached, we pass the response back, no matter what. That's it for our custom handler. Let's make sure we use this. For that, let's open a new service, the HTTP handler service. Let's implement the basics. Let's add a few using statements. There's nothing we haven't done before to see here. Then let's add a new method, getMoviesWithRetryPolicy. The implementation of this method is exactly the same as the one from the previous module, where we try to fetch a movie that doesn't exist. Like that, we can test that our custom handler actually retries sending the request, and we can test that it doesn't do that infinitely. Alright, let's make sure we call this method when we run the application. And let's make sure the HTTP handler service is registered on the container. We do that in the program class, as we're used to by now. There we go. So far for that, but we still need to ensure that the handler is added to the pipeline. Let's scroll up a bit. As you remember, this is where we configured the Movies client, including the primary HTTP message handler. The primary handler should be the last one in the pipeline. If we want to add another handler before that, we can call into add HTTP message handler. Like that, we start building the pipeline. In our case, we want to add a new retry policy delegating handler. Let's say we pass in 2 as the maximum amount of retries. The handlers are added in the order we registered them, and the primary message handler is always the last one in the pipeline. Let's set a breakpoint in the for loop of our custom handler, and let's give this a try. We hit our breakpoint for the first time. So far, so good. Let's continue. And we hit our breakpoint for the second time. This is good because we know the request to fetch that movie will return an unsuccessful status code, a 404 not found. This means that we're going to try this again. And that's exactly what this code shows us. Otherwise, in case of a successful status code, we would have returned a response. Let's continue. And there we go. We still get back a not found, as you can see, but we also see 2 other things. 1, we don't retry again, which means the maximum amount of retries. And 2, we only see the final message, the requested movie cannot be found, written out to our window once. This means that only after 2 retries, the actual response is returned to the calling method. So far, so good. Now let's try sending a request to a movie that does exist. I happen to have the URI of such a request laying around. Let's give this another try. Within our custom handler, so far so good. And there we go, we get back a successful response. That's an OK. So our retry policy doesn't send the request again. One last thing though. We still have 2 constructors here. One that accepts the maximum amount of retries and one that does the same but also accepts an inner handler. We've only used that first one when we configured our HTTP client. But we haven't used that second one yet. So why did we write it then? Let's open our HTTP handler service. The thing is, not everyone uses HTTP Client Factory yet, although it is the best practice and I would really advise you to. But if you can't, you can still chain handlers together using that constructor we just wrote. Have a look at this code. It's much like what we've done before using the HTTP Client Factory. Then we used a static HTTP client instance and we configured the HTTP client handler to allow automatic gzip decompression. Now, that HTTP client handler is the last handler in line. So, if we want to add our retry policy delegating handler before that one, we can do it via the code on screen. Like this, we can build a pipeline. A client is instantiated, and we pass through the first handler in the pipeline. By using the second constructor, we pass through the new HTTP client handler as the inner handler for that retry policy delegating handler. Like that, we're building a pipeline of handlers. Alright, that's it for this demo. Let's continue by looking into timeouts. Sometimes requests timeout. In fact, if you tried the previous demo yourself and kept looking at the breakpoints for too long, you will have noticed that after about 30 seconds the request timed out, as that's the timeout we set. But it times out with a task cancelled exception. We learned about that in the module on supporting cancellation. We also learned that the .NET Core team is thinking about implementing out-of-the-box support for differentiating between a timeout and cancellation. Until that is implemented, we have another good use case for a delegating handler. We can use that to throw a timeout exception instead of a task cancelled exception. Let's do that in the next demo. In this demo, we'll create a new delegating handler, this time for handling timeouts. So let's add a new class. We'll name it Timeout Delegating Handler. It again derives from Delegating Handler, which is defined in system.net.http. If we're going to catch timeouts, it's a good idea to allow inputting a time span after which the request should time out. So we add a field for that with the default value of 100 seconds. That's the default timeout value of the HTTP client. We add two constructors that allow inputting a value for set field, one with and one without the inner handler, just as before. Then we override the sendAsync method, also just as before. Let me paste that in so we can run through it. This requires a bit of explanation. To implement this, we're using a new cancellation token. The idea is that we will cancel the new token when the timeout has been reached. If that's the case, we can catch the operation cancelled exception, and then we're sure that we're timed out. If not, cancellation happened through some other means, which means it wasn't the timeout that caused the exception. We create a new linked token source from the pass-through cancellation token. That linked token source will ensure that when the original cancellation token reaches a cancelled state, the new one will get cancelled as well. So by doing that, cancellation still works. We cancel that token source after the provided timeout value. Then we send the request passing through the token from the linked token source, as explained earlier. We catch an operation cancelled exception. This will happen if cancellation of the original token happens, but also after the current timeout has been reached. When we catch that exception, we can check if cancellation was requested on the original token. If that's the case, a timeout wasn't the issue, so we rethrow the exception. If it is the case, the cancellation was caused by the linked cancellation token source.cancel after timeout statement, which means we can safely say it's a timeout, and we thus throw a new timeout exception. That's it for the handler. Let's open the program class and register it. We know how to do that by calling add_HTTP_message_handler. We want to make our timeout delegating handler the first one in line, because if the maximum amount of time has been reached, we want to cancel no matter what. Important here is ensuring that the timeout we set on our handler is lower than the timeout specified at HTTP client level. Otherwise, we'll just end up with the task cancelled exception again. We do not have to change anything to our handler service, as the HTTP client factory will provide it with an instance in the way we just configured it. Let's give that a try. First, let's see if it works without timing out. And there we go. This works as expected. Now let's try forcing a timeout. One option would be to write some dummy code at level of the API to ensure that the process to get a movie takes long enough. But with a timeout of just 20 seconds, there's a good chance that once you enable debugging at level of your API, it'll take at least 20 seconds for it to start up. So let's give that a try. For that, let's click Set Startup Projects at solution level, and here we can see that we're starting the Movies API without debugging. Let's start it regularly, and let's have a look at what gives. Now let's wait a bit. And there we go, we see a system.timeout exception, as expected. In case your machine is faster than my machine, you might want to fiddle a bit with the timings, but this does show the principle. Let's look into a few other use cases for delegating handlers.